Hello students, I'm Swapnil Sir and welcome to yet another video on our channel. So already we have started lecture series on pair of straight line. As board exam is coming closer, so we are focusing only on previous year questions from the board exam. Okay, and some of the recap videos from our topics. So if you are interested to see similar videos, do check it out in our playlist. You will get the similar videos there. So in our today's video lecture, we are going to understand some of the basic concept from the pair of straight line chapter, and along with that we will solve some of the previous year questions from the 12th HSC board exam question paper. Okay, so as exam is coming closer, so I'm expecting that you all are preparing well. Okay, so now let's get start our today's complete lecture series on a pair of straight line chapter. Okay, so first of all, we'll go for some of the basic concept understanding, and then at the end we'll move for the some previous year question paper which repeated multiple times. Okay, and maybe there is a possible chances that these examples may become in our coming exam. Okay, so we all have to be prepared with these examples. Maybe 99% chances are that examples may be asked for your board exam. Okay, so without further ado, let's get start our today's lecture. So first of all, we'll go for the some of the basic concept, and then we'll go at the end we solve some of the questions from previous year board exam question paper. Okay, so here our today chapter completely based on the pair of a straight line. Okay, so already we have uploaded a full video, one short video on a pair of straight line. So if you wanted to see each and every concept in detail, you may check these videos too. Okay, let's start our today's lecture. So here in my today's lecture, we'll go for the first recap of our topics. Okay, so in our pair of straight line, what we learned at the beginning, we learned general form of the lines. Okay, general form of the line in our xy plane. Okay, so what is the general form of a line in our xy plane? Okay, so before we start our questions from board exam questions, we have to be familiar with some of the concepts. Okay, so it is the general form of equation of a line in our x and y plane. Okay, so in our x and y plane, general form of a line, says that when we have equation ax plus by plus c which is equal to 0, whenever we have the equation x plus by plus c which is equal to 0, what the equation represent here, which is the involvement of a x and involvement of a y, it is there. That means this equation represent our xy plane. Okay, so if we are going to plot this equation in our xy plane, it gives us some type of a straight line. Okay, and you all are familiar with plotting a straight line or plotting of any line in our xy plane. Okay, substitute the value for x, you will get the value for y, and plot of this value together in our xy plane. Okay, so it gives us whether a straight line or maybe some type of the curves are coming. Okay, so probably consider that in our pair of straight line, always already we have to think only about the straight line which comes under x and y plane. Okay, so we are not thinking about the curve or any curve shape. Okay, so we only go as per the straight line from our general form. Okay, so whenever we have x plus by plus c which is equal to 0 in our xy plane, so it represent general form. Okay, it represent the equation of a straight line in our xy plane. Okay, so here first topic, it says that the combined equation of a pair of lines. Okay, combined equation of a pair of line. So what is mean by combined equation? As already you have learned combined equation or a separate form of the equation in our quadratic equation. Okay, so what we do in a quadratic equation, we try to find the factors from the equation. Okay, and these two factors are coming separately. Okay, these two factors are coming separately from one single quadratic equation, so we call it as the two separate equation. Okay, what we call it? Two separate equation. Two separate equation, what we call for it? Two separate equation. Okay, that means it is a two different combination for one line, we consider convert it into the two different line. Okay, so we consider under it as the two separate equation. Okay, and whenever we have two separate equation, and when we take together of this equation, it comes as the combined equation. Okay, so first of all we need to understand how can we separate equation and how can we combine equation. Okay, now let me consider two separate equation, and we are trying to convert it in the combined equation of our line. Okay, now I consider here general form, so try to consider two separate equation which is suitable for our general form. So I consider here a1x plus b1y plus c1 which is equal to 0, and another equation a2x plus b2y plus c2 which is equal to 0. Okay, so we have these two separate equation. Okay, these two separate equation. Now we want the combined equation from these two separate equation. Okay, so how can we find combined equation using two separate equation? Just we need to multiply both of them, like when we have u which is equal to 0 is a single line, and v which is equal to 0 which one is the another line. Okay, so u which is equal to 0 first line, and v which is equal to 0 which is the second line. Okay, so we have these two separate line here. Okay, and the combined equation of these two line, it says that when we take u into v which is equal to 0. Okay, so this separate equation get converted into the combined equation in our pair of straight line. Now see that in our algebra we have just some basic calculation over here, just to multiply polynomial, divide them, or we are taking as addition subtraction as the part. Okay, so in algebra we don't have to deal more calculation, but just need to understand some basic concept, how we can find combined equation, how we can find separate equation. Okay, now see that we have u which is equal to 0 and v which is equal to 0. These are the two separate equation of a line. Okay, and when we take it the combined equation, we get the u into v which is equal to 0 as a combined equation of a line. Okay, now see that this one is the first equation, this one is the second equation. Okay, so we have two different equation. Now let's find out how we can take the combined equation using both of them. Okay, so just multiply both of them, like a1x plus b1y plus c1, multiply this equation with the another a2x plus b2y plus c2, okay, which is equal to 0. What I have done, I have first equation u as a a1x plus b1y plus c1, and another equation v as a a2x plus b2y plus c2 which is equal to 0. Okay, then their combined equation, it represent as a1x plus b1y plus c1, a2x plus b2y plus c2. Okay, now as we do a regular multiplication between two brackets, similarly we have to follow this one here. Okay, so multiply a1x to the entire second bracket, b1y to the entire another bracket, plus c1 to the third this bracket. Okay, so you will get the combined equation of a two line. Okay, so that's it only here for the definition of a combined equation of two different lines. Okay, or you may take two or more than two line. It is completely based on how many lines we have. Okay, so this one is only for the combined equation of pair of line. Now after that, homogeneous equation of a degree 2. Okay, homogeneous equation of a degree 2. Now let me explain what is meant by homogeneous equation and it's a degree 2. Okay, so whenever we have the power for variable which is a similar everywhere in our equation, okay, and the power which is a 2, okay, then we consider it as the homogeneous equation of a degree 2. Okay, homogeneous equation of a degree 2 means the equation whose degree which is a 2. Okay, but the degree which count therefore all variable need to same everywhere in our equation. Okay, so then we consider it as the homogeneous equation of a degree 2. That means those variable we have present in our equation, we consider it as the homogeneous equation of degree 2. Now let me take one of the example for homogeneous equation of a degree 2. So if I consider x into y plus y square which is equal to 0. Now see that we have homogeneous equation power 1 power 1. Okay, that means both of them are having power 1 plus 1 2, and y it is also having power 2. Okay, that means those variable we have present here all are the having power 2. So we consider it as the homogeneous equation of a degree 2, or maybe we can take the constant here as well. Okay, 2y square, but only homogeneous equation of a degree 2 which comes with the value of x and with the value of y. Okay, so this one comes under homogeneous equation of a degree 2. Angle between lines, so whenever we have two pair of straight lines, so between the line, whenever we have intersection point, okay, so for getting an angle between two lines, at least we needed their single intersection point. Okay, so if I consider these two lines, okay, now see that we got those some theta here. Okay, so the angle between these two lines, it represent here as a theta. Okay, this one is a angle between two lines. This one is the angle between two lines. Okay, so this theta we consider as the angle between two lines. Okay, for finding the angle between two lines, at least we need single or one or more than one point which intersect in our line. Okay, so we consider it as the angle between two lines. Then after that, general second degree equation in x and y. Okay, so the general second degree equation, it says that x square plus twice of hxy plus by square plus twice of jx plus twice of fy plus c. Okay, this type of the standard equation, or we consider it as the general standard equation of a degree in x and y. Okay, these all points are come under our pair of a straight line. Okay, maybe there are so many other points as well. Okay, but we'll see it later on. First of all, we go for some of the important example which asked in our previous year board exam question paper. Okay, now let's move for the next topic. I hope you all have understood that recap of our today's lecture. Okay, so first I have taken one separate equation. Okay, find the separate equation. Now question, it is from the March 2013 board exam, asked for 4 marks. Okay, which is from the March 2013 board exam, and question, it says that find out the separate equation of a line. Okay, so what we want here, we want here separate equation. We want here separate equation, okay, of a line. Okay, okay, separate equation of a line here. And now we and represented by the line given here. What is the equation of a line? 3 times x square minus 10 times xy minus 8 into y square, which is equal to 0. Okay, so this one is our combined equation given. Okay, so this represent as the combined equation. Combined equation of pair of a straight line. Pair of straight line. Okay, this represent combined equation of a pair of a straight line. And as we as earlier we have explained, combined equation of a straight line, it says that whenever we have two separate line u into v which is equal to 0, so which represent as the combined equation of a straight line. Okay, so in order to find out their separate equation, we generally used to find their factors. Okay, generally we used to find their factors, so we get the combined equation of a pair of a straight lines. Okay, so for this what we do here, we try to find first of all u which is equal to 0 and another v which is equal to 0. Okay, so these two are separate equation of a line. Okay, let me write it one more time. Okay, so u into v which is equal to 0, which is a combined equation. Then their separate equation, u which is equal to 0 and v which is equal to 0 is it is the separate equation of these lines. Okay, now what we do, we try to find first of all the factor of our given quadratic equation. Now we can see that here we have 3 times x square minus 10 times xy minus 8y square. Okay, which is the standard homogeneous equation of a degree 2. Okay, so how we count the degree power of our given line? Okay, now see that x is having power 2. Okay, that means which is the power 2 for x. Okay, so x is having power 2. Similarly, we can say that because x is having power 2, that means we consider it as the homogeneous equation for our degree 2. Okay, so it matters here whether power 2 or not. Okay, now let's go for the x and y. Now we can see that x is having power 1 and y is having power 1. That means both are having their combined power as a 2. Okay, so the next term it represent power 2 and third term also it represent power 2. Okay, that means three of these terms gives us the power 2. So means our given equation which represent homogeneous equation of a degree 2. Okay, in x and y. Okay, so our equation is in the form of degree 2 of homogeneous equation. Now what we do, first of all we are trying to extract our equation and find out the separate equation. Okay, so 3x square, keep as it is 3x square, because we don't have to do anything with that 3x square. As we try to find the factors from our quadratic equation, similarly we have to follow this method here for finding the factors of a given quadratic equation. Okay, now see that minus 10xy can be written as minus 12xy. Okay, minus 12xy plus 2xy. Can we write this one is minus 12xy plus 2xy as a minus 10xy. Okay, so 3x square as it is here, minus 10xy I have written, minus 12xy plus 2xy minus 8y square. Okay, minus times 8y square, which is equal to 0. Okay, so I expanded our given term in this form. Okay, so let me change the color. Okay, so see that 3x square minus 12xy plus 2xy minus 8y square. So if you know the proper way for finding the factor of a polynomial, so maybe you may go from by using other way too. Okay, for finding their factor, because as we have last term which is in the form of a y square, so we cannot apply directly the formula for quadratic equation like x square plus bx plus c. Okay, it cannot be applicable. So to apply this formula, you have to divide y square throughout and try to convert 8y square in some constant term. Okay, so once you get that constant term, further calculations are easy. Okay, now see that here I taken 3x square and minus 10xy as a 12xy plus 2xy. Okay, take possible term common from here, so we will get the u into v form here. Okay, so see that we have 3 into x same term here, so 3x common from here, so it will remain x minus under bracket. So we have taken 3 common, that means 3 4s are 12. So under bracket we left here with the value 4y plus. Okay, now 2xy it is there, take 2y common from these two terms. So 2y common under bracket x minus 6y. Okay, x minus 6y. So is it possible to take common? No, 2x, sorry, x minus 4y. It is not the 6y. By mistakenly, I have taken 6. It's not a 6, because when we multiply that 2 into 4, we get the required term as a negative of 8. Okay, which is equal to 0. Okay, now see that x minus 4y and x minus 4y both are having same terms here. Both of these are the same here. Take it once, take out from this bracket. So x minus 4y, which comes out from this 2 1, and under bracket 3x plus 2y. Okay, which is equal to 0. So we got this equation as a u multiplied by phi, which is equal to 0. This is the form of u multiplied by phi, which is equal to 0. Now see that we have multiplication of a two polynomial is 0. That means one of them need to be a 0, then and only then their multiplication it goes to 0. Okay, now that means x minus 4y, which is equal to 0, or 3x plus 2y, which is equal to 0. Now see that we got the required answer x minus 4y, which is equal to 0, and next 3x plus 2y, which is equal to 0. That is only the step we want in our example. So that is required separate equation of our pair of a line. Okay, question asked in March 2013 for 4 marks. Now see that how easy questions are coming in our board exam. Okay, I'm expecting that you all have understood my solution. Now let's move for the next example. So it's not an example, it is an important theorem. Maybe this one is a very much important for your upcoming exam. So you all have to prepare it well. Okay, and I'm also going to be going to explain this example here, theorem here, and I will put you here, put some of the important tricks and results here that you can remember this theorem for your exam. Okay, so question asked for 5 marks. Okay, you know, in your board exam, that question asked for 5 marks for March 2014 exam, March 2016, March 2018, after that October 2015, February 2020. So multiple times that question repeated in our board exam. Okay, so how many times? 1, 2, 3, 4, 5, 6 times that question repeated in our board exam. Okay, how many times? 6 times. So maybe past year that question it is not there in our question paper. Maybe this time we have 99% chances that question it is coming in your board exam. Okay, so prepare it well. So it there are plenty of the chances that question it is coming for your board exam. Okay, so let me explain the proof of this theorem. Okay, so we have here, prove that homogeneous equation of a degree 2 in x and y, that is homogeneous equation given of a degree 2, which is a x square plus twice of hxy plus by square, which is equal to 0, which represent a pair of a line through the origin if h square minus ab greater equal 0. Okay, now before I start this theorem, okay, I wanted to explain to you all some of the concept related to the algebra. Okay, sorry, geometry. So okay, so algebra, so you all need to know there is no any concept like imaginary numbers. Okay, in our algebra. Okay, so that's why we have to avoid negative of 1 under square root in our calculations. Okay, so see that what we have given, homogeneous equation of a degree 2 in x and y. So first of all, write down what we have in our question. Okay, so we have homogeneous equation of degree 2 in x and y. Okay, we have given homogeneous equation of a degree 2 in x and y, which is a x square plus twice of h xy plus by square, which is equal to 0. This one is the homogeneous equation of a degree 2 in x and y. Okay, so first we have x to the power 2, that means first variable gives the power 2. Second, 2h is having multiplicand variable as a x and y, that means x power of x is 1 and power of y is 1. Okay, so their combined power it gives us a 2, and similarly for by square. Okay, so y it seems that y is also having power 2. Okay, so all our quadratic equation are having and their variables are having power 2. That means everywhere power 2 in our equation, so we consider it as the homogeneous equation of a degree 2. Okay, and which is in the form of x and y. Okay, and then we have to prove here our claim. What we have claimed, it represent pair of a line through the origin if and only if, what we have claimed, when h square minus ab greater equal 0. When h square minus ab greater equal 0, then and only then it represent pair of a line. And what did it represent? Our homogeneous equation of a degree 2, it represent pair of a line, okay, of a degree 2. Okay, so let's go for the proof. So here we have to consider 2 of the steps. Okay, so which based on the by square. Okay, so we cannot make ax square 0. Okay, so if we're going to make ax square 0, that we cannot define our line in our xy plane. Okay, so make sure that we do not want that ax square 0. That means the term of x we always wanted to be there in our equation. Okay, that means by square maybe it goes to 0 or maybe non-zero. Okay, but ax square plus twice of hxy, we always want that term as a non-zero. As you can see here in our my figure, x plus twice of hxy plotted here, x plus twice of hxy with the x which is equal to 0 line. Here we have 2 thetas given along with the x and y axis. Okay, so here we can see if you want the value for x and y to plot in our xy axis, we need to be we have to make that x non-zero in our xy plane. Okay, so see that only we have possible chances that we can make a by square 0 or non-zero. Okay, So using this, try to make two different cases. First case for whether if b non-zero, and second if b which is equal to 0. Okay, when we have b non-zero and b 0. Okay, using these two conditions will prove the statement of our theorem. Okay, now first of all, condition for b which is equal to quite easy. B which is equal to 0, it is quite easy. So try to prove the b which is equal to 0 condition in our theorem. Okay, so what we have here, x square plus twice of hxy plus by square. Consider first case, if b which is equal to 0. Okay, if b which is equal to 0, but where in x square plus twice of hxy plus by square which is equal to 0. Okay, and when we take b which is equal to 0, we left only with the term x square plus twice of hxy which is equal to 0. Okay, so where that by square goes, because we have taken b 0, that's why by square it completely goes to 0. Okay, so we have term left here x square plus twice of hxy which is equal to 0. Okay, now what we do, take similar term common from our equation. So it's x and x same here. Okay, so we can take x common from there. So x under bracket remain ax plus twice of hy. Okay, 2 times h y, x square plus twice of hxy plus by square which is equal to 0. Okay, now what I have done here, I have taken x common from our bracket. So we left here the value with the x into x plus twice of hxy twice of hy which is equal to 0. Now see that we have multiplication of a two bracket which is a 0. That means one of them need to be a 0 here. Okay, that means x which is equal to 0 or ax plus twice of hy which is equal to 0. Okay, that means one of them need to be a 0. Then we say that the multiplication of a two bracket, it is coming 0. Okay, now we can say here we have two different equation, their product is 0. That means both are the combined equation. Okay, this is the combined equation of our pair of straight line. Okay, and this one is the separate equation. This one is the separate equation of our pair of a line. Okay, so we got the two different equation. Okay, these are the separate equation. Now we can see that whenever we take b which is equal to 0, it is an obvious case that our line represent pair of a straight line. Okay, so and which passes through the origin. Now see that x which is equal to 0, can we say that x which is equal to 0 passes through origin? Yes, surely. Obviously x which is equal to 0 which is passes through origin, that means this is the point of our origin. Okay, so x which is equal to 0 always passes through origin. Then next equation left here, x plus twice of hy. So whether it is passes through origin or not. Okay, so if you're going to plot this equation, so obviously we get the x plus twice of hy which is equal to 0 which also passes through origin. Okay, so means without having any condition, we can say if we take b which is equal to 0, then our equation pair of a straight line, equation of pair of straight line passes through origin. Okay, so I'm expecting here you all have understood first part of my theorem. Okay, this one is the first part of my theorem, and it says that our equation of a line, pair of a line which passes through origin. Okay, now we have left the condition with if we consider case second. If we consider case second, what we have case second, if b which is equal to non-zero. If we take b which is not equal to 0, and if b non-zero, then we left here only with the term x square plus twice of hxy plus by square which is equal to 0. Okay, so that means b non-zero, that means we are getting our equation of a pair of a line which is as it is, x square plus twice of hxy plus by square is equal to 0. Okay, Now see that, try to convert our equation in some standard form that h square minus ab will be appear in our equation. Okay, so what we do, take by square to the other side. Okay, so we will get the x square plus twice of hxy to the same side. Okay, okay, so take this one to the other side. We have to make solve this equation further. So x square plus twice of hxy plus twice of hxy, which is equal to minus of a by square. Okay, now see that, try to complete this square of our term. Okay, so we have only the first two terms. It is a part of a completing the square of our term. Okay, so we have here x square plus twice of hxy, which is equal to negative of by square. Okay, so what we do here, we are trying to take the square from our term. Okay, by square it is remain. Okay, try to take the square from the both side, will get the next equation. Okay, now what we do here, go for the solving our equation further. Okay, so we also take that twice of hxy to the other side, we get the equation. Okay, so by square plus twice of h xy, by square plus twice of hxy, which is equal to negative of ax square. Okay, now see that we have here by square plus twice of hxy, the variable which present here and the variable which present here and here. Okay, so it is not in the form of a complete square, so try to divide throughout by y square. Okay, so if we divide throughout by y, then we will get as a form of hx. Okay, so if we take h and x, okay, so first term is there b into y square and second term is h into x. Okay, so combine both of them here, so we'll get the b y square plus twice of h xy, by square plus twice of h xy, which is equal to negative of a into x bracket square. Okay,